Hello students, in this video we'll see an example of changing a triple integral from Cartesian coordinates into cylindrical coordinates. Let's find the triple integral over a region E of z plus x dv, where E is the region between the cone. The cone is z is the square root of x squared plus y squared. That's a right circular cone. And the cylinder, and that gives us a clue this problem can be put into cylindrical coordinates. And the cylinder, x squared plus y squared is equal to 4. So if we sketch this region E, what do we see? So here's the x-axis, here's the y-axis, and then here's the z-axis. The cylinder of radius 2, so that should be radius 2 obviously, looks like this. And all the cross sections are circles, like that. And so we're above what? So in the xy plane where we intersect this region, I intersect at the unit circle, or the circle of radius 2 in the xy plane. Now the cone will look like this. So the cone starts over here, and it goes up. And at some point, we don't know what point that is just yet, at some point that cone will hit the cylinder, and I'm after the area in between the cone and the cylinder, so this region over here. So I basically drill a conical shape out of this solid cylinder. So what we'll do now is we'll parameterize this region in cylindrical coordinates. Notice that our region lies above the what? Our region, E, lies above the circle of radius 2, centered at 0, 0, in the xy plane. So that tells us that our angular variable theta is between 0 and 2 pi, and our radial variable is between 0 and 2. Now we have to find the z variable. Well, the z variable starts over here in the xy plane, so z starts in the xy plane. That corresponds to z equals 0. And then z goes all the way up to what? All the way up to that cone. Z ends on the cone. So that is z equals square root of x squared plus y squared. And this is exactly equal to r. So my values of z go between what? My z goes between 0 and r. And so now we can actually write down what the integral is. So the integral is going to turn into the integral from 0 to 2 pi for my theta, the integral from 0 to 2 for my radial variable, and then z goes from 0 up to r, 0 up to the cone. Then z in cylindrical coordinates stays as itself, so z is just z, and x turns into r cosine theta. Then I have an r dr dz d theta. And of course, the z has to come first because I have the r over here. So let's put the z variable first. So I have an r dz dr d theta. Now my limits are in the right order, right? The z variables go over here. And so now let's do the integration. So I'm going to do the z integral first. I'm going to have the integral from 0 to 2 pi, the integral from 0 to 2. Then I'm going to have a z squared over 2 for this z integral over here, and that's multiplied by r, so z squared over 2 times r. And then this r squared cosine theta squared gets a z, so I have an r squared cosine theta, and that gets a z. And z goes between 0 and r. Then I have a dr d theta. And so let's plug in r over here. So what we'll have is we'll have the integral from 0 to 2 pi, the integral from 0 to 2. This will be an r cubed over 2. So I have an r cubed over 2. Plus this term over here will be a what? Will be an r cubed cosine theta. So I'll have an r cubed cosine theta over here for the next term. And then we'll have a dr and a d theta. If we look at this second integral over here, when I do rectangular separation on this second integral over here, I'm going to have to integrate cosine between 0 and 2 pi. But the integral of cosine between 0 and 2 pi, if I integrate between 0 and 2 pi cosine theta, d theta, that is equal to 0. So this term will drop out when I do rectangular separation. So I'll just do rectangular separation on the first term. So when we do that, what happens? So that term is going to go to 0, right? Okay. And so what we'll get is we'll get by rectangular separation the integral from 0 to 2 pi of d theta times the integral from 0 to 2 of what? Of r cubed over 2 dr. And so let's finish this. So this is going to be a 2 pi for the theta integration. And this is going to be an r to the 4th over 8. So we have an r to the 4th over 8 from 0 to 2. And so what we'll get is we'll get a 2 pi. And then this will be what? So a 2 to the 4th power is 16. 16 over 8 is 2. So 2 pi times 2. So our answer is 4 pi. Thank you very much.